Welcome to Betatalk, and today's podcast episode is the last one in the series about the Heat Pump Ready program, which was a program initiated by the Department of Energy Security and Net Zero. So the opinions you'll hear in this episode are mine and my guests, and they are not the opinions of the Department of Energy Security and Net Zero, or anyone that works in that department. So my guests are the fantastic Madeleine, Gabriel. You might have heard Madeleine on some of my podcasts previously. She's the mission director at Nesta. We've all heard of Nesta. They're my favourite think tank, charity, whatever, however they describe themselves, talking about this sector. And you've also got another great entity, Carbon Trust, who do lots of work around this industry. And we've got Will Rivers back on the podcast to chat with us, because they were heavily involved with the Heat Pump Ready program. And correct me if I'm wrong, Will, we've got a kind of another one starting, haven't we? That's what we're going to chat about.
Yeah, thanks for having us on again, Nathan. Really good to be back. So DESNZ, as part of the Warm Homes Plan, the Heat Pump Ready 2 program was announced. So it's kind of a £30 million extension to the original Heat Pump Ready 1 program. We're not directly involved in that, but I know that the team at Department for Energy Security and Net Zero are really keen for us to kind of help spread the word. And yeah, I'm sure we can talk about some of the details on that on this podcast and encourage maybe some of the innovative people in the sector out there to get involved.
So, and it was all about innovation, wasn't it? So just, I suppose for the listeners, give us a brief synopsis of what that Heat Pump Ready 1 was about, what it wanted to achieve, if it achieved it.
Yeah, sure. So Heat Pump Ready 1 was an innovation program funded by the Department for Energy Security and Net Zero. It was a £42 million program. It funded, I think the final count was 44 projects. There was about 180 different partners involved in the consortiums across the projects. 11 of those projects were under the high density deployment stream. So this was the stream where they were trying to get to 25% of people in an area upgrading to a heat pump. And that was very challenging, but really, really interesting learnings there. And then the rest of the projects were under what was called the innovative solutions stream of the program. So this was everything from trying to improve the customer journey, a lot of things looking at how we improve survey and design processes. One of the big successes, I'd say, was around heat pump and home energy management optimization. There's definitely a number of good projects on that front. It was quite diverse, everything from kind of financial products, as well as some manufacturing and kind of tech innovation projects were in Heat Pump Ready 1.
And Madeleine, Nesta's very much involved with innovation, isn't it? I mean, how do you get involved with innovation?
Yeah, thanks again for having me on, Nathan. Great to be here with you, Will. Nesta gets involved in innovation in a few ways. We work directly with other organisations to design and test solutions to some of the challenges that we see in scaling up low carbon heat. And we also directly support innovations through what we call our Mission Studio, which is basically a programme of support for setting up new businesses in the low carbon heat space. And the way that works is that we look at opportunities for innovation where we think a venture-backed business could work. We then recruit a founder to build that business. We support them for 6 months, and then hopefully they can spin out of the studio and work as an independent business and raise money.
So, I mean, do we both agree that innovation... Well, what I'm going to ask is innovation important in this? So obviously, as you both know, you know me well, I've grown up in the heating industry. We are in an energy transition. There's some stuff we've got to do. I mean, do we need innovation, or is there specific areas where we need innovation? What are your thoughts on that, Will?
Yeah, I think if you think of innovation just purely in terms of changing how we do things and trying to do things better, then I think it's absolutely a very clear case that we kind of need to do that in the heat pump sector. We're still, despite several years and lots of money in trying, very much in the kind of innovators phase of the adoption curve for heat pumps. We're not really even into early adopters technically. And so there's a lot of barriers, for want of a better word, to heat pump adoption that need solutions. And I think, if you think of this in the context of, well, Heat Pump Ready is a £30 million programme. In the context of a £15 billion warm homes programme, I think it's kind of really reasonable and justifiable to say, yeah, let's spend some money to try and think about how we could do some of these things differently, overcome some of these kind of quite significant challenges to kind of widespread heat pump adoption.
And it's quite I didn't realise that. So like you just introduced us to the Heat Pump Ready 1, that was 42 million. So this is kind of near the same ballpark. We got 30 million, because there was, like, you and I know, because we were both, well, I think I was the only person in the country that was involved in Stream 1, Stream 2, Stream 3. There was a lot of people and a lot of entities and a lot of consortiums involved in that Heat Pump Ready 1. So, and this is going to be quite a big one in its own right, isn't it? Or are they going to support, do you think, fewer consortiums but with more money?
I think that it seems like there's a few different focuses, but yeah, I mean, you're right. There's a lot of people involved, and I think probably a lot of people will be surprised at some of the kind of innovations that are out there that they didn't necessarily know at some point had Heat Pump Ready support as kind of part of their overall process. Heat Pump Ready 2, it sounds like there's going to be a bit of a change in focus. So software projects were a reasonably big focus of Heat Pump Ready 1. That's not going to be the case in Heat Pump Ready 2. It's going to be much more focused on essentially things that can be deployed in the market and in homes by 2030 at the latest. So I think they're looking for technologies that have had some kind of development and proven in a laboratory or energy house or something like this, TRL level 5 at least, for those people who kind of follow those types of things. And over the course of between 2026 and 29 can get to the point where they're ready for deployment by this 2030 date. So yeah, it's similar to Heat Pump Ready 1, but there's a shift towards things which will really kind of get out there into the market. The levels of funding are similar, so it's between 200,000 and 2 million each kind of individual project could apply for. So it's, that's pretty much the same, I think, as what Heat Pump Ready 1 was looking at.
And can people that are in that Heat Pump Ready 1, let's say consortiums that were in the Heat Pump Ready 1, can they apply for Heat Pump Ready 2?
Yeah, I think that, they can. I think that it has to be led by a private company based in the UK. So it can be an individual or a private company. It can be a consortium, and that consortium could include academic partners, public sector, third sector, and so on. Which I think is the same as Heat Pump Ready 1. So yeah, they could apply, but as I say, there is a slight shift in focus towards more technology in-home being deployed than, I guess, Heat Pump Ready 1 had more of a focus on kind of earlier stage innovations and innovations which helped things a bit more around the edges of, if you like, of kind of in-home technology. So things that just improved survey and design, or things that just improved the customer journey on a website, for example.
And if we look at the consortiums that we had first time round, there's some nice consortiums, wasn't there? There's some of them were quite large. They had all sorts of different entities or people involved. Sometimes an academic institution was working alongside a few other entities. I mean, is there restrictions on who gets involved? For instance, Madeleine, if someone came to you with an idea and said, look, would you be part of our consortium? Are Nesta allowed to get involved in this, or do you work in a different sort of way?
Well, that's an interesting question. I think we could have got involved in Heat Pump Ready 1, so maybe we could in Heat Pump Ready 2, technically speaking. We've tended not to do that directly, just because of the role we play in the sector and the size of team we are. But yes, I think the idea of consortium that include innovators and others around them makes sense.
So I'll ask you this again, because Madeleine, the Nesta, I always get this. I think you own BIT now, the Behavioural Insights team, don't you? Which was a government thing set up whenever it was set up, and it's all to do with behavioural science, really, isn't it? And how we can change behaviour with nudge theory and things like this. Do you see, because I do, I mean, I'm not trying to put words into your mouth, do you see that as innovative? I think there's as much as technological innovation, I think we need innovation around behaviour change. My degree's in behavioural study. I've obviously got my industry qualifications, my teaching qualifications, this kind of thing. But I did do a degree, and I find it quite fascinating, psychology and behaviour, because we've got two aspects. We need to change behaviour of society and consumers, and I think we need to change behaviour of the people in my sector, the engineers. I think there needs to be a behavioural change. So I think there's definitely some innovative things and exploration around that. I mean, would you agree with that?
Yeah, I think that's a pretty good summary. And yeah, you're right. Nesta owns Behavioural Insights team now. It's a consultancy that, it's fully owned by Nesta. I think I would say a couple of things about that. Where would I start? I think as a consumer, I've recently got my own heat pump, and I'm now learning what it's like to live with one and how to experience it as a consumer, and that's helped me realise a bit more some of the sticking points and barriers that Will talked about. I've got a great heat pump. It was a really good installation. It's a Valent heat pump. It's one of the most advanced, but at the same time there were things that were, I would say, little niggles or things when I was just getting used to running it. It wasn't nearly as simple as I was expecting. And I'm someone who has been working in this area for the last 5 years or so and really interested in heat pumps, and I think about them even when I'm not at work. So I was a bit surprised at, that it wasn't as smooth a user experience as I was expecting, just getting used to the heat pump and working out how to use it and how to optimise it alongside a tariff and so on. And I think there's really a lot of room for making that much easier for consumers and probably for installers and others who are involved in getting these technologies into homes. And I think that is related to behaviour change, but it's not about necessarily trying to get consumers to actively change their behaviour. It's about changing the environment around them so that those choices are easier to make. So I should, as a consumer, shouldn't really be having to look at my tariff and work out when it's going to be cheaper to run my hot water. It's much better if that can be optimized automatically for me. I think currently I'm not using optimization software. I am doing things manually because I just like to learn how it works. But in the future, I would expect that to be, much more built into the offer that customers get, whether that's packaged up with the hardware or with a tariff that comes along with an installation. And that's just one example. But I think changing that wider environment around a consumer and how they use this technology is a big part of where I see the innovation already happening and where I think it will come in the future.
So there's an awareness piece. Like I say, it's not about getting them to change a specific behaviour, but people becoming a bit more aware. And it's a very interesting point. And like you say, you've been around this sector talking more about heat pumps than most people I know. And I know a lot of people talking about heat pumps. But And so I suppose that's been a good experience for you, because you read loads and loads of reports, you read loads and loads of stuff about customer journey, etc., etc. But now you have one yourself. There's these nuances that are now sort of starting to engender themselves and think, oh, right, okay, that's going to be problematic for some. Because, like I say, you're in the ball, you know the industry, but so many people won't, will they? That most homeowners have got far, far more important things to do than think about their heating. So, yeah, I mean, I'd be looking forward to seeing if there's any sort of real good innovation around this awareness piece, behavioural change piece. Obviously we've got the technology there, and we can always innovate around technology and make things better, and also things like supply chain. So we've got an issue at the moment with heat. I did a post the other day. I think it upset some people, but there's a lot of heat pump manufacturers. There was 54 I named in the UK, and they're all competing against each other. And some are having supply chain issues and issues with getting people out to repair them in time. So things like logistics. So there's a very, very well, I won't name them, bless them, but there's a very, very well known, probably make one of my favourite products for a specific niche in the heat pump market. They've changed their logistics company about 4 times, and they're struggling to get stuff out to engineers at a time when we're trying to convince society this is good stuff to have. We're trying to convince engineers to switch. And so these little niggly problems have a massive effect on a sector that's trying to sort of grow and help in all sorts of ways. So I think innovation around things like that, which we don't often think about, is, logistics of getting heat pumps to people's homes. I mean, do you think we'll see sort of innovation around that, Will?
Yeah, I agree. I think that's fundamental. And what I hear quite a lot is that there's a lot of inefficiency just in that supply chain that could be one of the critical ways in which kind of costs overall could come down if these supply chains were more sophisticated. Essentially, it's not an area I'm close to at all, but that's what people say. So yeah, I agree. That's definitely an area. Is it worth me kind of there's 4 areas that DESNZ have said will be in heat pump ready 2, but they have said that these are a draft and they are kind of actively looking for people to kind of say what they think should be the priorities. So I mean, it might be interesting to list them, and then we can have a bit of a debate about what else we think could go in there. So the first one is around the capital cost of heat pump system and hardware components. So I think that's kind of very much on the kind of manufacturing and potentially supply chain side. The second is around kind of minimizing the in-property changes required. So how can we potentially reduce pipework changes, emitter changes, cylinder installations, things like that. The third one is around internal and external space requirement, which is a kind of a barrier that we're all very well aware of to mass adoption. Madeleine, it'd be interesting kind of how you fitted it into your flat or house. And the fourth one is around time. So time taken for heat pump install from an accepted quote. So they've kind of listed 4 kind of quite specific challenges, some of what we've just been talking about, I think does come under there. But as I say, they are kind of actively consulting on these in terms of what other people think are really critical things to go in there.
Yeah, so the installation time isn't, well, that's kind of always been something front of mind for lots of people, isn't it? Because it's a big barrier for the consumer. You know, then if the heating goes down and it's a new boiler and they need a new boiler, the boiler can't be repaired for whatever reason. You know, they can generally get heating within a day, if not the next day, and that's not the case yet with heat pumps.
Yeah, it's interesting actually. Kind of in the presentation, they talked about the overarching aim being heat pumps become the desirable and natural choice for households replacing an existing heating system. So they are kind of very much thinking that you know, to get to a mass market, we know that something around 60% of heating system installations are at the point of replacement. People aren't just kind of waking up one day and deciding to replace their heating systems typically. So yeah, so I think, I mean, it's hard to disagree that is a key one. I mean, yeah, I'm interested in your guys' thoughts on this. I feel like there is, so I mean, Adil from Heat Geek would phrase this as until heat pumps offer kind of similar running costs or cheaper running costs than gas boilers, we don't have a market. So just the kind of very issue of the performance, the level of efficiency, you know, we know that in electrification of heat versus, for example, heat pump monitor system, heat pump systems on there's kind of a 37% difference in efficiency between the kind of average installations, if you like, and the really good practice ones. And those really good practice ones are at that point where we've got kind of cost parity with gas boilers. But there's kind of a big proportion of the industry, if you like, that obviously needs some kind of change or help to bring those kind of standards of commissioning installation up. So yeah, I wonder if that is kind of an omission that would be good to kind of also think about and feedback.
Yeah, it's this spark gap. Do they still call it the spark gap, Madeleine? But I mean, are we going to see any changes? I mean, you'll probably hear more than most. I mean, is it getting better? Are we going to get that sorted?
It is getting a bit better. The April price cap was announced this week, and that's seeing the spark gap narrow a bit. It's actually currently at the widest it's been since the energy crisis, I think. So we're currently at about 4.7, a ratio of 4.7 between electricity and gas prices. But from April, it's going to come down a bit to about 4.3, and then probably a little bit further down in July. And that's partly because government took some costs off of electricity bills in the autumn budget. So you might remember banging on about levies on electricity bills for ages, as a lot of people in the policy space have. Essentially, a lot of costs have been loaded onto electricity bills that aren't on gas bills, and over time that's pushed the price ratio wider. Government took some of those costs off, particularly mainly the renewables obligation. A large part of that came off electricity bills and has been covered by the Exchequer instead. And it also, as you'll know, removed the eco levy from both electricity and gas bills, so that programme has been stopped. And as a result, that's reduced the ratio a bit, but there are some new costs going on to electricity bills. Network costs have gone up, so that's counterbalanced some of the gain. Anyway, long story short, the price ratio is narrowing, but it's not coming down as far as we'd need it to get that push that Ardil talks about. It's essentially, if your price ratio is 4.3, then you need a heat pump that's 3.8, 3.9 efficiency to be that many times better than your average gas boiler, and that's just to break even. And ideally, you would want a heat pump beating gas. I mean, I suppose to that point, though, I mean, my experience so far is that it is possible to save money with a heat pump as long as you're using a time of use tariff and using it well, and it's a good installation. So there are, you can save money with a heat pump now, even with current electricity pricing conditions. And I think we need to make sure that people do understand that, as well as understand that it's possible to have higher bills at the moment if you don't do those things.
Yeah, well, I'm going to pick up on that point about open energy monitor wheel. And so as we know, the electrification of heat project and the previous studies around heat pump efficiency back in the day, 2009, 2011, by the Energy Savings Trust, didn't have particularly good results. And as we've seen from Open Energy Monitor, they do have good results. So these things can be put in properly where, even despite this big gap between gas and electric, you can have cheaper heating. But I just want to point out for the listeners, a lot of people that installed them heat pumps on Open Energy Monitor have only been installing heat pumps for a very short amount of time. In fact, some of the people who are getting very good results aren't even plumber heating engineers. They're the people that started Open Energy Monitor. They're Glyn and Tristan. They put their own systems in. So when I chat to people, because there's people behind the scenes that will argue at me saying heat pumps aren't great for these properties in the UK because of these studies, I always then say and highlight the Open Energy Monitor, go and take a look. There's quite a lot of systems on there. They always come back with the argument, yes, but these are like the top engineers, and we haven't got an industry with all top engineers. And I'm saying, well, there's a part of that's right, but when you say they're top engineers, some of the people that are getting good results have literally, they're self-taught. So that's that thing that Madeleine knows I always bang on about, self-directed learning. It's not courses. They've had a passion to learn something, which is very easy to do now. They can go on LinkedIn and interact with good engineers, especially people in the guild, learn the stuff they need to learn and go out there and do a really, really good job. And funnily enough, it's the companies that have been involved in the heating sector as long as me, that were involved in their energy saving trust projects and the electrification heat projects, that were getting it wrong. So there's a thing there that, if we find what we need to do to make the ones that have been getting it wrong, who've been in my industry for a long time, in the industry I'm in for a long time, to then make them think, oh, right, okay, it's self-directed learning, because it's not as hard as what people think. If you're very used to, you're going in homes, meeting with customers and drilling a hole through walls and laying pipe everywhere, if you just know a few certain things that the good engineers are utilising, you'll put a good system in. Because like I say, Tristan and Glenn, lovely, lovely people. I think they're some of the best people historically this industry's ever seen, as well as John Cantor. They didn't do what I did. They didn't do an indentured apprenticeship, and they're just geeky, wonderful people that thought, we're going to put our own heat pumps in, and they've done a bloody good job. And they've got a very, very good performing system. So it's not hard to achieve. And I think if we wait for the attenuation of this gap between, we won't get anywhere. So maybe that's another area where we can innovate. Again, that's a behavioural change. How do you get? I know incredibly great engineers. I'm not going to name him, but if a hospital went down tomorrow and their plant, and no one's getting heat in that hospital, he's the guy you want. He can walk into that complex plant room. I wouldn't have a bloody clue what was going on in that plant room. I grew up around industrial plant rooms when I worked for the MOD. I wouldn't have a clue now, but he's the person you want. but he still struggles to sort of understand the nuance of how heat pumps can heat a home, etc., etc. So that's a behavioural thing, which is obviously the area I'm very interested in.
Yeah. The other thing to say about those heat pump monitor installations and the installations on there. So I think the average of the heat pump monitor installations, I'll get this wrong, but it's around 3.7, something like that. But we've actually been doing some work with John Eubank and Tristan and Glyn, because they're not all exclusively perfectly commissioned or perfectly set up systems, even on heat pump monitor. If you take out the kind of 20%, which you think actually kind of aren't running continuously on weather compensation and all these things, then the average kind of shoots up well above 4 for the kind of well-commissioned systems. So it's like you say, it's a hugely valuable reference case and data set for kind of what these systems are capable of. I think, to kind of come back to the point, I think it's a really how you get installations that are performing down, between seasonal performance factors of 2 and 3 up to 4, for me is a critical thing about how you build the market. And I think so. We've been doing some research for the Committee on Fuel Poverty and DESNZ recently, which has involved going into a lot of fuel poor households who've received measures under kind of various fuel poverty programs, and coming across, I guess, standards of installation or standards of performance that make even electrification of heat look quite good. So there's clearly large sectors of the industry that aren't up there with those kind of self-directed learning sides of the sector. I mean, one of the things I've taken away from that, I think, is that there is, I guess we went into that with a bit of an assumption that maybe fuel poor households are not operating their systems optimally. They're kind of turning them on and off a lot. They're kind of, maybe behaviors are kind of part of the reason why they're still seeing high fuel bills, for example. I think we're coming out of that much more with a sense of, actually people's heating needs are really quite simple. It's not that they have a really complicated pattern or that different people need different types of heat. They just need heat either continuously, or some of them don't need it continuously, but they always want a warm house. It really is the kind of the controls and how the heat pump is responding to their quite basic needs that is the issue. I think there is a lot more innovation and responsibility that we need to put back on the installers and the manufacturers of how this kit's set up. So yeah, I agree with your point about user education and things being crucial. But as you said, most people who don't work in the sector have got interesting lives to get on with. They just want a really simple interface that does what they need us to do. And I think until we get to that point, it will always be a losing battle of trying to educate people about weather compensation. That may happen for some elements of the able to pay sector. Most people just aren't there. And I think we quite often forget actually about the, nearly half of installations that have gone in under the last few years have been under kind of fuel poverty programs, not the boiler upgrade scheme. And these are very different transitions for people. It's either an involuntary transition where the housing association or somebody else is saying, we're going to give you a heat pump, or it's a kind of semi-voluntary transition where it's an owner-occupier, maybe with lower income, who is being given a free system and so is willing to accept it, but hasn't kind of been through the same journey of, this is a really exciting piece of kit that I'm going to learn all about. And so I think, these aren't people who aren't capable of doing that learning. We've interviewed retired software engineers and retired electrical engineers, but people are just not that motivated to kind of do the kind of learning that we might do.
Yeah, it's about activating them to be. I mean, that's one of the principles of Beta Teach, activating people to be autonomous learners, self-directed learners. Some people do it naturally. Some people just wake up one morning and think, I'd like to learn about that, and go and research it. Other people, you kind of have to find ways to activate that in them.
I would build on Will's point around, the technology needs to fit people's needs rather than changing the people to try and fit the technology. And I think there is a risk that we focus on behaviour change and things like, oh, well, people have been heating intermittently and they just need to learn that heat pumps have to be on all the time and it's their problem, and think more about how the tech interacts with them. I mean, the point I was trying to make at the start was that, as I say, even as probably a relatively sophisticated user, I was quite surprised that I had to find the right weather curve for my system through trial and error, and that software definitely has the capability to do that for me. I shouldn't have to do that, I don't think. I found it an interesting process, but I can't imagine that most people would want to do that. And I just think we need to design those sorts of things out, and we have the technological capability to do it. One thing I think is really exciting, definitely relating to innovation and what we were talking about regarding Open Energy Monitor, is that we now have so much more data available, people making it open, which is fantastic, and trying new things and sharing what they're finding. And that does lead to innovative thinking and innovative approaches. We're seeing people comparing and contrasting a weather compensation based control strategy with actually something that's just optimizing for the cheapest electricity at any time of day, and challenging some of the received wisdom about whether the curve is the best way of controlling your heat pump. I don't know where things will come down on that, but I think it is great that people are starting to say, okay, but what if we experimented this way? Can we actually get a better result? I know there have been some tests looking at, well, how much worse is intermittent heating really? I think there will be an efficiency penalty, but it also might be cheaper in some circumstances. I think we do need better data and better experimentation in order to inform how we help people use these technologies most effectively, rather than feeling that everyone has to learn about them and change their own behaviours.
That's the other tenet of Betatalk: activate people as learning resources for one another, which is peer-to-peer stuff, which is, again, you've got the Open Energy Monitor crew, have got a lovely forum, and it's not just engineers on it, it's just interested people on it, or people that have got heat pumps on it, and everyone's learning from each other. It's fantastic. Do you think, actually remind me, one of you, that I want to talk about air-to-air and whether that we're going to see innovation, because obviously, as you know, Madeleine, Andrew Sissons from you're from Nesta, him and I chatted about air-to-air, and some things have been happening in that kind of piece of it. Do you think, so we all talk about this transition. Now, when people talk about transitions in my industry, the example I give, I remember listening to someone in the energy department give an example, and it's usually the gas transition from from manufactured gas, which was coal gas, to natural gas, and it was an amazing transition. It only took us 10 years. But there is another transition that no one really talks about, and that's the transition to central heating. So people heated their homes for a long, long, long time, whether it was a coal fire in a castle or your cottage out in the middle of nowhere. We've had coal fires for 100 years, and we had things like your gas fire in your lounge, or your electric 3-bar fire in your lounge. I grew up in the 70s, where I think the electric wasn't coming on for a few days, wasn't it? So we would have paraffin heaters. And I remember my babysitters getting taught to light the paraffin lamps, when mum and dad went out. And then there was a transition to central heating. So central heating is where you kind of heat every room with a central device. That transition took arguably 40 years. So 50s, 60s, it started to slowly come in. Late 60s, 70s is when my grandfather was involved in it, in early 80s. Even though my dad was a heating engineer, I didn't grow up in a home with central heating until 1981. So he didn't put that heating system in till 1981. So that's, even though he's got a father-in-law that's been involved in it for donkey's years, there was a slow transition. So there's a part of me that thinks this will just we've got the population's grown since the 60s massively, and there's a part of me thinks this is going to have to naturally be a slow trend. It won't be as quick as what people think, no matter how much money people push into it and try and incentivize customers to buy new heating systems. I think it's going to be slower than what we think. Now, that obviously then causes problems for people that are perhaps not sort of so much worried about heating, but are obviously on the sort of debate around net zero decarbonisation for climate change and things like that. They want quick solutions, but I don't know if it will be quick. I don't know what your thoughts are on that.
I mean, my thinking on that is that the reason I'm interested in heat pumps, or the reason we're putting heat pumps so central to the debate around net zero. You will not see a kind of pathway to net zero to 2050 that does not involve masses and masses of heat pumps. And there's a really clear reason for that, and it's because they're the great multiplier of renewable electricity. If you're just putting in electric heating, you need kind of 4 times as many wind turbines and other ways of producing renewable electricity. So from an energy systems point of view, we don't have another way of decarbonising the housing stock that fits with how, the amount of renewable electricity that's likely to be available and so on, other than heat pumps. And that, to be honest, for me, is kind of how was my journey into heat pumps. It wasn't that we did the EST field trials in 2010 and they worked so brilliantly and the supply chain was kind of clearly ready to deliver them that we said, oh, let's just replace gas boilers because these are much better. If anything, it's been the opposite. So kind of, I guess we're coming from this from the point of view of we have to make heat pumps better. In order to get to net zero, we have to make them the default choice. I think, by brilliant coincidence, they can be. As we said, Heat Pump Monitor demonstrates that they can outperform gas boilers even on a standard tariff. Throw into that the fact that we're moving towards a more flexible grid and time of use is going to be really critical. Throw on top of that solar PV and things like batteries are kind of massively coming down in cost and are so much more accessible. So, by happy coincidence, it is possible that they can also be the better technology. But I guess we're coming to this from a view of how do we address these challenges to make sure that that happens, rather than rather than just letting this play out naturally, if you see what I mean.
Yeah, I would say that I think the 2 transitions that you mentioned, Nathan, are really interesting because they're very different from each other and they took different amounts of time and you could probably learn different things from each one. So the town gas to natural gas transition was really planned, state-driven, top-down, and actually very quick. And it did include some similar things to what we're talking about here. We had to have engineers going into houses and changing appliances and all of that type of thing. Whereas the central heating uptake was much more consumer driven, wasn't it? It was people seeing it in other people's houses and thinking, well, this is so much better than having open fires, and took longer, arguably maybe a bit more similar in terms of the changes to houses that we're talking about. So, whole new infrastructure and so on. But then, I don't know, I'll be interested in your views on how much more difficult it is to change a whole house from not having central heating to having central heating versus adding a heat pump to an existing central heating system. I think there's some similarities. I would suggest it's maybe a bit quicker and easier, and that we've talked about some ways to make it easier still. But basically my point is, I think if the will is there, we could do this transition relatively quickly. We're not ready to do it at mass scale yet because, as you've said, the supply chain isn't quite there, and we need to make sure that installations are good across the board and that people understand this technology, even if I'm arguing that they shouldn't have to, get really deeply involved with it. But I think we could be in that position in a few years' time if we put our minds to it. And I also think there's a bit of a virtuous circle because the more we're doing of it, the faster we'll learn. And if you take the view that this can't happen quickly, well, it won't. It will just be a trickle because we just won't get that critical mass fast enough.
I'm actually going to retract that because I've just realised while listening to you two, yes, it was a slower transition, central heating, but that's because society was, we are now living in, for some reason, we're on this exponential curve, aren't we? I mean, my daughter's only 13, but if I look at what was happening in society when she was born to now, in the last 2 years, all three of us, I'm now talking to AI nearly every day. Oh, can you give me a business plan for this or something? To conceive of that, 10 years ago, if I was to say to someone that was a very, very good software person in this world and said, in the future I'm going to be chatting away to something sort of chat back to me, they'd have thought I was nuts. But so everything seems to be moving so fast anyway. So perhaps that's part of it. The transition will be quicker because that's just how things are moving now, quicker. We still aren't going to escape the problem that society, people still have other things to worry about, more things to worry about than their heating. I know there's lots of research saying your average, and you might have done the research, Madeleine, I know others have, that people are very concerned about the environment, etc., and they are thinking about this. But, the people I meet, the heating system isn't front of mind at all. They've got lots and lots of things to worry about in their lives. It's when they're getting a survey or a quiz put in front of them and say, "Do you care about the environment?" Most people are going to say yes. Do you? So again, we've got trying to help people become aware that there is a change happening, and it does involve heating systems. And like you say, I sometimes worry where some people think they're getting forced on them, and there's a lot of people that have had these heating systems who are having to now negotiate them. How do I work it? How am I supposed to live with it? And you're well clued up, Madeleine, and know all sorts of people in this. And even you found it. That's interesting. Then there's been a bit of a problem to get that all sorted, but so it's going to be a lot harder for your average homeowner in their journey.
To bring it back to, heat pump. You look at the challenges in heat pump ready too, and I think so. Yeah, most people have much better things to think about and much better things to spend money on than their heating system. But pretty much everybody will replace their heating system between now and 2050, and I think the kind of innovation case is about when they come to that point. Is the sector, is the technology, is the installation process, the capital cost in a place where they go, oh yeah, heat pumps are kind of the superior choice now. I know that. They've been demonstrated. My neighbour's got one. My installer is now so confident in them that he's willing to recommend it over the gas boiler, even if there is still a bit of a additional capital cost maybe. So I think, that is what these programs are trying to do, isn't it? Is move the market onto that point. And it's interesting in the UK context. It's kind of the most challenging context for a heat pump market in a way, isn't it? Because we've got such an extensive gas grid, because we have such a high spark gap. So these things have to be even better in the UK than they do in France or Norway or kind of other countries that don't have the same systems. So I think it kind of strengthens the case for why you need these kind of innovation programs.
Air to air, would that be? Do you think people would be creating consortiums to sort of get involved in the air to air side? I think. Well, have you heard any sort of people? That aspect of it.
So you've got So the forward capital cost of heat pump system hardware and components. Arguably, air to air could come in there. People should look at the detailed criteria. In property changes required, again, arguably, in some cases that could be air to air. Internal and external space requirement, again, you still need a cylinder, but and time taken for heat pump install from accepted quote. I think there's kind of air to air is not mentioned specifically, but is definitely in scope, and I think could be some innovations around it could be in there. One of the key things is that this won't fund technologies which are already at market. So it's not looking at kind of increased deployment of existing solutions. It's looking at kind of new ways of deploying these technologies and bringing those to market. So it would have to be some kind of innovation around air to air or using it in a different way, I think.
Well, using it in a different way is interesting. So obviously, you both know me well. People who are very dismissive of heat pump technology will always bring up the cost, and I try and explain. Well, it's not just a heat pump. You're changing your system a little bit. For a start, you're putting something outside. Your boiler's not outside, so you've got to get electric outside. You've got to get some pipes outside. You might have to build a plinth for your heat pump. So there's cost involved in it. But I also then point out to them, I can buy 4 separate heat pumps for the same price as a normal boiler easily, as anyone could. You could. I get obviously good discount, but anyone could. Air to air stuff's very cheap. Now, when I say things like that, then people say, well, yeah, but if you put it in a home, you've got to have something in every room, because we're all now used to having a radiator in every room. So everyone thinks something's got to be in every room. Now, going back to that transition period I was talking about, we transitioned to central heating. We didn't have everything in one room. We had a gas fire in one room. We all lived happily. Yes, our bedrooms might have been a bit cold. I grew up, there was frost on the inside of windows. But you can put technology in. And so at the moment, the mindset seems to be we put a heating system in, it has to do everything. It has to do everything on the coldest possible days in every single room. Now, I've worked in a lot of farmhouses, a lot of rural properties that for the most day of winter, when it's around about 9 degrees, if they've just got one air-to-air heat pump in their living space downstairs, it's heating their living space in their kitchen quite fine. And yes, they could have the odd boiler come on a bit later if it's going down to freezing temperatures. But I think we've got this, and I can understand why the bus grant focuses on, right, you've got to make sure the whole system can do the whole thing. But, I've had people come up to me and say, well, could I just put one of these mini splits in there for, cost 500 quid to buy, obviously you charge to put it in, and that's going to heat my downstairs when I'm downstairs for most of the heat. And I go, yeah, it would. And what about the bedrooms? Well, your bedrooms are going to get a bit of that heat, but if it's quite a mild winter's day, you haven't really got to worry. And if it is a horrible day, you've still got your old system. And this is how we used to use heating. So you had coal fires and and I sometimes worry people think a heating system has to do it all, everything. And I don't think that's the best way to think. I understand the grant systems are sort of framed around that. But for air to air, because it is so, and we're solving the problem of decarbonising. Because if you're heating at home, you're going home and watching whatever you want to watch on TV, and you've got your little air to air silently running away, keeping everyone comfortable, and it's on. You're not burning fossil fuel. We're achieving the goal we want to achieve, aren't we?
Yeah.
Yeah, I think that's maybe where some of the behaviour change you're talking about comes in, because people are really interested in cooling, and every summer comes around, it's hotter than the last one, and people start talking about air conditioning and probably not realising that that's the same, that technology can also heat their homes, and that just feels like a really big opportunity. Like you, I can really see why government has focused the grants on getting the whole house away from fossil fuels. And I think it probably would be difficult for them to say, we'll grant fund a partial system, partly because people might then just use it for cooling. And I think that's one of the things that they've been thinking about quite a lot. But nevertheless, if people are investing in this technology anyway, and it can do some heating for them, and they're thinking more about that than just the cooling side, I think that would be a really positive opportunity. I think the other thing that we could explore further is thinking about hot water and space heating separately, and whether there are opportunities to use different technologies for those two, even within, say, a boiler upgrade scheme funded heat pump installation. So say that's my view, not anyone else's view, but I think there's an opportunity there.
You picked up on another good point there, because the other thing that central heating engendered was you kind of did your hot water and space heating from the same appliance, and that's new as well. So when, like I say, going back to the home I grew up in, Dad had put a cylinder in, and it had an immersion heater, and then he changed it over to what we call thermal siphon. Some people call that a gravity system. So he put a solid fuel Franco-Belge in, and it thermo siphoned up the cylinder. So it did a bit of the space heating. It wasn't connected to any radiators. So we've always used to have hot water as a kind of a separate thing to space heating. Central heating kind of brought it all together. So when I say to people things like, you could have your air to air, you could put an air to air in there quite cheap. Oh yeah, but don't do hot water. And I'm like, well, there's other ways you can do hot water. When I taught at colleges and in the prison, we teach about hot water, and there's so many ways you can heat hot water for domestic use. There's lots of great innovation around. We've had people like Mixergy and all sorts of people. Even your Tepios and the sun amps, thinking about, there's different ways of doing hot water. It's nothing you have to be worried about. You don't have to worry it's not being done from the same thing as doing your space heating. There's other things you can do for hot water. Mm. And I think that's another behavioural mindset thing, I think. And that's how we kind of used to live. Hot water was kind of a separate thing to space heating back in the day. So that's another good area of innovation, I think.
Well, and it's also the biggest internal space requirement, which I think for kind of most homes is going to be probably the more critical one. And talking about heat pumps becoming the desirable choice, that is an incredibly undesirable thing for a lot of people, to lose several cubic meters of their house. With property prices, it's several £1,000s worth of space you're losing, right? So I think solutions for that will be really, really, really critical for mass market uptake.
We want a combi heat pump, don't we?
Yeah. Well, yeah, there's great innovation going on already around a lot of this stuff. It's not, and over the last few years, it's not all kind of through these kind of government funded programs at all. There's tons of research, I know, and, have to kind of shout out Heat Geek on the the cylinder front, done some really great innovations there.
Yeah, that's a very important point. That is actually possibly, it's in the top three, isn't it? So when people get put off with heat pumps and they have got a combi system, I mean, people think there's still quite a lot of cylinders out there. Otherwise, the cylinder manufacturers wouldn't be making money. There's a few million still out there. But there's a lot of homes that haven't got them now. And the space where they used to be is now a different space. Some people sort of knocked that wall out, made it into an upstairs ensuite. That became a bit of a popular thing when I was sort of on the tools. People having en-suites here, there, and everywhere. And so that space requirement for your cylinder is key. There's innovation around putting it outside and things like this, but of course some people don't have space outside. So space, and we all live with more stuff now, don't we? We all live with more clutter, so we're always looking and scratching around for more space. That's another area where innovation is going to be quite interesting, I think, isn't it? Domestic hot water.
Yeah, and as Will said, there is already some innovation out there. Heat with their mini stores. I think they've also been experimenting with a type of combi system. Right? They put some experiments up online around that. You mentioned SunAmp that takes up quite a small amount of space. If you're taking a boiler out, you might be opening up some cupboard space in your kitchen. You can perhaps move some stuff around and then slot something smaller in. But I agree, this is an area that if you could find some really scalable solutions that don't take up too much space, I think that would remove a significant barrier for people.
I think it has to come from both sides, isn't it? I think that there's all kinds of instances of things that are desirable. People are willing to accept disruption and maybe loss of space. Like a dishwasher would have been something at one point that you had to find space for, but nobody complained about that because it was a really desirable thing for most people. If you can get heat pumps to the point where they are seen as the kind of desirable, superior thing because they are cheaper to run, because it's more consistent heat and so on, and at the same time kind of minimize these things in terms of the space you need, alternative solutions for kind of awkward spaces, and address all of those things, make it something that can be a semi-distressed purchase, then I think you kind of have a fighting chance of getting people at that key trigger point, don't you, of the replacement.
I mean, we could all go back to washing in cold water again. I mean, I do sometimes say this to people because we're all nice and young, aren't we, us three? But my dad's only 81, but he's the generation that didn't grow up with hot water. They literally, he's the copper bath generation. You only had a bath once a week if you're lucky, and it was usually a copper kettle on a stove of some sorts. And if we look at water, and we're all obviously talking about transition because it's all about energy. Water has one of the highest specific heat capacities known in the universe. What that means is it takes more energy to heat water up than nearly most other substances in the universe, which is why we use it for cooling things like nuclear reactors and car engines. And it's very new in human society that we've heated water up. We're fanatically obsessed with heating water up. We all love a coffee. I love a coffee. We've got millions of coffee shops around this world constantly heating water for our addiction to coffee. And hot drinks only came around because people back in the day had to boil water to sterilize it. That's why hot drinks, no one has to drink a hot drink. Humans do not have to drink hot drinks. So if we were really in this major crisis, if some aliens come down and said, look, you're in a real crisis, you've got a year this planet to survive, you've got to stop eating water up because that's where all your energy's going. Because no one needs to, people say, yeah, but you need to wash in hot water, Nathan, because it kills your germs. No, it doesn't. You need to wash in 60 degrees plus to kill bacteria, and 60-degree water will give you third-degree burns in 3 seconds. No one can wash in 60-degree water. So we've got billions of taps everywhere now where we go, and it's comfortable to wash your hands in a hot tap when it's winter, innit? We don't like cold, but you don't need that. If you're working, let's say you're a car mechanic, you've got lots of oil on your hand, yes, hot water does help that soap interact with the oil, get that. But we've all, in just one generation really, become obsessed with hot water, washing in it. So, I grew up just getting flannel washed. We had a bath, me and my brothers once. We all had to jump in it together after football. But we flannel washed. But we're now in, I've met some very, very, very passionate people about the environment. But I don't know if the word fanatical is a nice word, but I'm going to say they're quite fanatical. And they will shower 3 times a day. So they get up early in the morning, have a shower. They go to a job where they are lucky enough to go out for a jog in the midday. They come back and their workplace has got a shower. They have a hot shower. They have a bath at night. They're going into their Costas doing some work with. And I try and point out to them, well, you're a bit of a part of the problem because we're part of all the millions. I'll do it. You know, I'm not. We're all part of these millions that are using so much hot water. The world has never seen this before. It's only in our generation. The amount of hot water we are using is incredible.
Well, I don't want to get all Monty Python grumpy Yorkshireman sketch, but I used to live on a boat that had an LPG water heater, an engine calorifier, and a solar PV diverter heating system. And there were times when none of those 3 systems were working. So I'm no stranger to cold showers.
Yeah.
But is this going to be your innovation application then, Nathan?
No, it's not. I just think it helps people ground. So obviously we're all so used to heating and we're also used to hot water. But I think if people sort of sometimes get grounded a little bit, well, actually that's very, very new in human societies. We're trying to, people are trying to save the planet. We're trying to save energy, and hot water, it's a lot of energy to heat water up, an incredible amount of energy to heat water up. And we all do it willy-nilly, don't we? We talking about Monty Python. Monty Python come and stayed at the house I used to live in when I lived in New York, because the guy I lived with, they were best friends with Terry Jones. And when they broke America in the 70s, they didn't know anyone. They came and stayed there. That's got nothing to do with heat pumps, by the way, everyone. But yeah,
you're right. Like going back to, you mentioned behavioural insights team at the beginning of this podcast, and David Halpern, who used to run behavioural insights team, is the founder. Was regularly invited, and still is regularly invited, to go on the radio and talk about behavioural issues. And during the energy crisis, I remember one time he was on Radio 4 talking about things that people could do to save energy. And he got obsessed with showering. He's saying, we shower too much, people should shower less often. And everyone back at base was like, David, don't say that in public. No, our recommendation cannot be have fewer showers. But you're totally right that, we've just become used to having to wash every day, and that was a relatively recent thing. And maybe that is where your point about behaviours comes in. It's actually useful just to remember this isn't the natural order of things. These are things that could be changed. I think that people are starting to be a bit more aware of water usage.
Yeah.
And I've noticed in some of my just conversations with friends that people are talking about washing some of their clothes less often, for example, because they recognise they don't actually need to be washed all the time, certain fabrics. And that is also one benefit of having adopted a heat pump. I now know how much hot water I have. And how much it costs to heat it. And I never had any idea of that with my boiler. So this is really quite good.
Yeah, behaviour change. It's an interesting topic, behaviour change, isn't it? And again, like I say, society's changing so quick. So perhaps it will become quite normal to change quickly. I mean, we're all using these phones that are supercomputers now, and I'm having to navigate that with my daughter. How much should she use these things? But they are important to that. Communication is very important for any demographic age group, and so maybe change will happen quicker, and that means we've got to innovate quicker, then, doesn't it? And that's why these programs are so important. Innovation.
One thing that surprised us with this fuel poverty research is that we were expecting people's heating patterns to be stickier. We were expecting that people would have come from intermittent heating, maybe been advised to keep it on continuously, but been resistant to that. And we're kind of finding that there's very little resistance actually to change when people are told. There are still some people who, despite knowing it's more efficient, it's just ingrained that continuous heating is not what they want to do. But that's actually been quite... we've come across that less than we might have expected. But a lot of people, the problem is a lot of people aren't kind of given a handover at this point. So there is...
Yeah. Coming back to sort of reinforce the point you made at the beginning, Madeleine, you're a heat pump owner now. Well done on that. I mean, you do know me well enough. I do criticise some of the people I know that go on and on and on about trying to convince society to have heat pumps and ain't got one themselves, and they could have one. But so going back to this point, you've got your heat pump installed. what would you say is the number one innovation around that being a better journey for you? So would you say it's all to do with this control thing? So rather than you actually having to work out what a weather curve is, I mean, arguably your engineer could have just set it up for you, maybe come back a few days later, commissioned it, or hooked it up to an optimization device that could do that. But would that be your number one thing for innovation around? So the consumer hasn't got to basically do anything. It goes in, it works when it needs to work. Because it'd be interesting for me. So in Sweden, for instance, and places like this where they've been used to this technology, they aren't having to work their systems out. I've spoke to people in Sweden, and they said, do you know what? We don't even actually know when it's on and when it isn't on. Because obviously they've got quite a drastic summer-winter shift, with sunlight as well as temperature. And the people I've spoken to said, well, I don't know when it comes on. It just does what it does. So they've obviously had that installed, or they've even moved into a house where they haven't had to really sort of know how it all works. It just does work. So I wonder what we're doing a little bit different, maybe.
Yeah, I mean, I should say I did get a really good handover from my installer, and he showed me how to use all the controls, and I think recognised that I was someone who was interested and would want to fiddle around with it. So I think if I just wanted it left on a setting that was likely to be a good one, he definitely would have done that. But yeah, I think it is that, the system, we have the software capability or the technical capability now to enable systems to learn from your behaviour, to learn from your home, how you use heating when you're in, what type of solar gain you get, and they could be self-commissioning and self-improving over time. And I think different heat pump manufacturers are working on that, and some systems are more self-commissioning than others, and there is quite a lot of innovation in the space already, which I think is a really good thing. And I do think as a consumer, you probably shouldn't have to think too much about this. You should be able to put in your preferences, and it should work out how to serve you most efficiently.
Yeah, I should point out it was Heat Pump Ready 1 that funded Homely to get their kind of smart thermostat tested in the Salford Energy House, and kind of demonstrate that I think it was 22% saving of an optimized weather curve versus a heat pump that hadn't had its weather curve set up. And then I think it was an over 50% saving of optimizing all of the weather curve, PV, battery, and time of use tariff. The kind of saving in fuel bills was kind of well over half. So I think there's definite, and I know there's debate that those savings wouldn't be as much if it was an optimized system already, if the installer had kind of fully set this up in a way. But I think it is absolutely the case, and we're coming across them a lot in the fuel poverty cohort, that there are systems that don't have weather compensation set up at all, or certainly not optimally. So yeah, I think there's definitely a really key role for that, and maybe ideally being built in at the manufacturer control stage.
Yeah. And going to behaviours, I mean, I think one of the reasons that sometimes happens is that installers are worried about homes not being warm enough and about people getting called back. So I think it may be in many cases, some cases, that some of those installers don't know how to commission systems well, but it could also be that they're quite risk averse. If you have a fixed flow temperature, then it's not going to get lower than a certain temperature in the home. Just put that on, it's safer. And I think if you could be confident that the system could work this stuff out itself and you didn't really need to intervene as an installer or a customer, then hopefully more people would get a better result.
Yeah, good people, Homely. Will very supportive of me, Homely, and they were part of that program. So, Madeleine, go back to your install. So, the person that came around did the heat loss. Did they use software for that, or did they do it by longhand, or were you kind of? I mean, you might not be able to name the particular type of heat loss system they used, or you might be able to, I don't know. But I mean, a little bit about heat loss because you've sort of been around this sector for a while. I mean, were you impressed with that, or do you think there's innovation around that area that still needs to be done?
Well, I was a Heat Geek Zero Disrupt install, so it was that system, and yes, it seemed really impressive. And because I was so interested, they even showed me how the iPad worked, which was really exciting. I got to partially LiDAR scan some of my own rooms. But more widely, I do think that automating or using software to support that part of the process of doing the heat loss survey and designing the system it's got to be a good thing. I mean, Nesta Nesta's supported Kano through our mission studio that I mentioned at the start, and they're one of the software providers. There's loads of others that are really good, like Spruce, and I think that hopefully will help standardise that process and both make it more accurate, but make it more similar across installers. And I think that's quite important from a consumer perspective, because one of the things that we hear most often from people who are trying to upgrade their own homes is that they feel really confused as to why different people are telling them different things about their house. So one side benefit I hope from more installers using software like that is that there is more consistency, or at least it's easier to explain why one quote might be different from another. And that's because one installer is optimizing for a higher efficiency, for example. But when people get very different answers on heat loss and on how much they need to update their internal pipework or radiators or so on from different installers, I think that really reduces their confidence.
I mean, just on that point, that was a really key focus of the Heat Pump Ready 1 project. So there was several projects looking at either how do you automate the survey and design process, or put it through kind of electronics. So Heatly is kind of doing similar job to the kind of Heat Geek iPad, for example. But build test solutions, Permetrics, Geo were all looking at kind of how monitoring can help the accuracy of those heat loss calculations. And I thought that bit was really interesting in terms of, so Build Test Solutions project really looked at what's the average difference between a co-heat test, which is, I guess, the kind of industry benchmark, and standard heat loss calculations that are done, and found that it was kind of huge. In 59% of the cases, it's overestimating by kind of significant margin, which I think is well known. And I think, there's a lot of software now, like Spruce is really adjusting the air change rates, for example, to be much more realistic than has been the case in SIBSI guides in the past. But yeah, I guess to reference one of the other projects, so Geo's project looked at taking the kind of build test solutions algorithm for calculating the heat transfer coefficient, but just basing it on historic smart meter data. So kind of essentially in 60 seconds, you can get a view on what the heat transfer coefficient of the property is, that is within, I think the average discrepancy to the co-heat test was about 22% versus 47% for kind of an old SIBSI ES 12831 survey. So I think it's probably a good example of where there is innovative solutions there, which you could kind of quite quickly build into a system to give you a really good sense check of what the actual heat loss is. And I know it's still not perfect. Obviously, it's kind of 22% average discrepancy still. But actually, kind of some of the work that Tristan and Glyn and others are doing are showing that oversizing isn't quite the issue that we once thought it was, in terms of, when systems are 2 times oversized or more, you start to see efficiency drops. But actually, somewhere around 1.3, 1.6 oversizing is actually beneficial.
No, I liked keeping up to date with all the innovation around that, because I started teaching people heat loss back in 2006. I was teaching prisoners heat loss back in 2006, so I've been around it quite a while, and the innovation around it's been. So I've worked quite a lot with Build Test Solution over the years. Really like their stuff. The issue, obviously, with their stuff is it's the longevity of the test, and of course you kind of have to rely on it outside being quite cold. They need a temperature difference for their algorithm to work. But then you had other things come up. I mean, I was when Heat Geek announced their net disrupt, is it, Madeleine? What's it called?
Zero disrupt.
Zero disrupt. I get people message me all the time. Some people message me to coerce me into talking about topics because they don't talk about them. They might work for large institutions, for instance. But I probably got more messages about zero disrupt than I've ever got. And people were quite interested in my take on it because I quite liked it. Because, yes, you just mentioned innovation there where people are looking at energy usage and they can try and then work out the heat transfer coefficient. The advantage Heat Geek had, they've got data from installations they've already done. So it's not just looking at energy usage patterns. They know the systems in these homes. They know exactly what these systems in homes because they kind of had the engineers that did them. So they then pull all that data together with energy use data, and they can, artificial intelligence makes some very, very clever assumptions. Because even though I was probably one of the leading advocates of heat loss, I started talking about it first really in sort of trade media when Heat Engineer came on the scene, for instance. And I tried to get people to understand, it's important. It's important we do this. It helps you understand how heat moves, rah, rah, rah. But there was a part of me, because then something happened. Everyone thought, quietly, every home has to now have this really super duper efficient heat loss. No, they don't. I could walk into my dad's home tomorrow. I've got no idea what the heat loss is, but I've got heuristics and tacit knowledge to give me a general understanding. The heat pump I would choose from it wouldn't be oversized or undersized. And I know the radiators are fine because I put them in years ago. There's plenty of radiators in that house. And the heat pump system that would be put in would be all right. It'd be quite efficient. And I wouldn't have to do any heat loss whatsoever. Because my tacit knowledge knows that home, I don't need to get and I can do it longhand. I used to teach people how to do it longhand. I don't need to do that with that home. I'll have an idea what it is. Now, I'm not saying to everyone go out there and do that, because people have been telling me but they're like these AI. If you put a lot of installs in with all different archetypes of homes, your AI systems are going to start to work out some very, very clever stuff. So obviously we had Zero Disrupt. EDF have got their one, haven't they? I mean, I like the Zero Disrupt one because they're also keeping very on top of how engineers do the installs. There's a peer network going on. They've done some good stuff. I never know whether a deal likes me or not, because I'm disruptive. I'll say things how I'll say it, and I get things wrong. I'll hold my hands up when I get things wrong. But I do think they've done some good stuff in this industry. They really have. And that Zero Disrupt really interested me, because you can train AIs to have tacit knowledge and heuristics. I've got, because I've been in the industry a long time, as others have, we've got these heuristics. We don't know how, we can't explain tacit knowledge. That's why it's called tacit knowledge. But there are things going on that we just know, that's going to work. We don't know how to describe why it would work or how I could explain how, but we know it would work. And I think AI this is going to be interesting for Heat Pump Ready 2 then, really. I suppose we're going to see a lot, because Heat Pump Ready was around 2022. I know nothing about AI. I think it was around then, but most people weren't using it. Now I think a lot more people are using it, and I should imagine innovators for the Heat Pump Ready 2 are going to be using a lot more AI, I'd imagine, wouldn't
they? I think so, yeah. I mean, it'd be interesting to see. I mean, you could argue that kind of Zero Disrupt and EDF's version, is it EDF Express or?
Yes.
Well, yeah. That's all kind of focused on that theme too of Heat Pump Ready 2, which is that minimizing the in-home changes required, which you could argue has been the biggest single thing to kind of help reduce the upfront installation costs in the last several years, by actually looking at what really needs replacing and doing that calculation of what efficiency you're willing to accept for what level of replacement of parts, essentially. So, I mean, it'd be interesting to see what else comes up under that theme and whether kind of similar type things emerge or other, I guess, more hardware-based solutions for doing that.
Well, it's been a great conversation. Madeleine, you mentioned about they took into consideration solar gain, did they, on your heat loss? You mentioned solar gain, didn't you?
I was actually thinking of Aera's heat pump technology, which I think says at least that it does, once you've had the heat pump installed, it will start to learn about how you use it and how your home responds, and it makes estimates about solar gain and uses, I think, weather forecasts to modulate what's the heat coming into the house depending on what the weather is likely to be like over the next day, for example. So I think I'm not sure how that played into my installation, but I have seen other installers exploring that.
Well, the only reason I mentioned it, because I mentioned to you before we went online that my niece is 18, so she wants to take her uncle out for a pint and her dad. But my goddaughter, who lives next door, has just come back from travelling, and her great-grandfather was Barry Parker. And for some of my listeners, they'll know who Barry Parker was. He was the first person in the world, I think, to start to think about solar gain. He's the master planner for the first world's ever garden city at Letchworth. And he went out to Sao Paulo in Brazil and designed a garden city out in Brazil and one in Portugal. And so that's my goddaughter is the great-great-granddaughter of Barry Parker. So we might talk a bit of solar gain or solar. So he wanted houses for poor people to be able to have lots of sunlight, gardens. I don't know if anyone's visited that sort of garden city, but and there's actually an exhibition about him going on at the moment in Letchworth. So we're going up there next week. Right, thank you, Will. Thank you, Madeleine. It's been a pleasure as always to speak to you both. Madeleine, I'll be seeing you soon. Just about 9 days, I think I'm up at Nesta, aren't I? And hope the listeners have got something out of this. If you are thinking of being part of a consortium for Heat Pump Ready 2, Will, I suppose there's some information on the website somewhere. They just type that into a Google engine, I suppose, would they? Heat Pump Ready?
Yeah, Google Heat Pump Ready 2. There's an expression of interest, I think, that people can fill in. There's slides from the webinar that Desnes ran, and all the information's on there. Definitely encourage people to check it out.
Brilliant. Thanks, guys. Thanks again.
Thanks, Nathan.
Thank you.
Free audio post-production by alphonic.com.